All right, questions about your homework? 27 and then the AP ones. That's okay. I'll do it again because Robert wasn't here anyway. Yes. Is it not 296? That would help. Okay.
So what's the goal here?
So, that's right. Go ahead. Explain it, Avery. Okay, no, there's not one like this on the quiz. This is the only one. This is why I told you use that little reference sheet. This one is referencing an inverse trig function. You can use the sheet on your quiz if you want to. We're just getting started. Your derivatives and integral sheet. Okay, lady, I like your nails. Look good. Which what? What'd you say?
I was asking one.
So the goal here, what we're doing, if we can't find the area under geometrically, we're going to find the antiderivative. And then after we find it, so if we've got the integral from a to b of f of x, are you? I probably am too. That's probably my weakness, is the geometric part of it. So I get that. So we'll find the antiderivative of f of x, which will be big F of x, right? And we will evaluate that between a and b. In other words, we'll find big F of b and subtract it from big F of a, which is just the antiderivative. Okay? So here, because this is the opposite of derivative, right? Integral is the opposite of derivative. Say right, because it is. Okay. So here, what, if you took the derivative of some function and you got 1 over 1 plus x squared, what was that some function? Inverse tan. And if you look on your sheet, that one's on there. So this is inverse tan. You don't really need it, but if it makes you feel comfortable to have it, if it's a security blanket, you can. Okay, so inverse tan, let me set this up and then I'll show you how it works. So how inverse tan works is it says, where is the tangent value there? So where is tangent 1 and where is tangent negative 1? And this is the one that I said I felt like there was that this should have been it. And this is the one I said I think it should be negative pi over 2. So where is inverse tan 1? On the unit circle as you go around. Pi over 4, right? So this would be pi over 4. Well, so that's what I was saying. Your domain wasn't restricted. It didn't tell you where to stay in this one, right? So I'm going to stay. What? And then in quadrant 3, it's also 1. Right? Think about the unit circle. But I'm telling you. No.
Are they all like these, or are they all
What do you mean?
like on the quiz? Are they all? Are there some geometrically, or
One geometrically. Then it's one we've done. Yeah. Thursday? Okay, where is it negative 1? And so I just clicked over to 3 pi over 4. Subtract those negative pi over 2. So anytime you do the inverse, that means, remember inverse is where x and y split, right? So you're really looking for where tangent equals 1. Not where, so what is the value where it equals 1? Anytime you have an inverse, that's what it does. So if I said What's the inverse cosine of 1/2? I'm going to the unit circle and I'm saying, where is the x value 1/2? Because cosine is that, right? So if I start going around the unit circle, the first time it's 1/2, if you look, I've got pi over 6, and pi over 3. Right. So the answer would be pi over 3. In other words, I'm looking at this unit circle and I'm saying these coordinates are 1/2 square root of 3 over 2. So where is cosine, which is x, 1/2? What happens right here? Where is that? Pi over 3. What do you mean, what does it do? Okay, so do you remember when we solved equations and we had something like the cosine of x equals, square root of 3 over 2, just so it'll show up. In order to solve that for x, I had to get rid of cosine on the left side, right? And what cancels out but inverse operations, right? So I would do the inverse cosine on both sides, essentially. And it would mean that x is the inverse cosine of the square root of 3 over 2. Remember doing that? And we did it a lot on our calculator. We didn't, because we didn't use the unit circle as much as we probably should have. But now I say, well, where is cosine the square root of 3 over 2? So back to that unit circle, pi over 6. So that's all it does. No.
So basically,
Yes. Every time. If you can find the antiderivative, that's the new stuff there.
you don't do oh wait.
Because whatever's in the integral here, we do the antiderivative of it, and then we go from A to B.
All right. Well, I have a question. What if it's like x squared?
Okay.
Would you do like 2x plus b or like?
Okay, but we don't need the c when we've got a definite integral. When we've got numbers to plug in, we don't need the c anymore. Now, when we get to indefinite, we'll have to go back to the c. But you're right. Let's say I have this. Is that what you said, x squared? So yes, this would be 1/3 x cubed. Remember, antiderivative, we add one here, and then we bring this whole thing and we divide by it. It'd be 2/3. Because the goal is whenever you take the derivative, you end up back where you were. And you're right, when we took antiderivatives, we threw a plus c on here, right? But we don't have to do that now because now we have these specific values that we're plugging into. So we would do 1/3 b cubed minus 1/3 a cubed, whatever those numbers were. Some of the integral rules too. It's like where you can split up the addition subtraction, but you can't split up multiplication division. If there's a coefficient in front, if I have something like, then I could make this, and of course if I had a and b, I could make this 2 times the integral of ab, because if it's a coefficient, I can pull it out, put it in front, all those rules.
Yeah, I don't remember
What else? Do you mean if I had something like negative a? I don't know. It was one of those that we went over. If I had to evaluate that. And you had to combine them to come up to the, yeah. This one? Well, so the first thing I always check for on these is to make sure my smallest number's on the bottom, because if the smallest number is not on the bottom, I need to flip the bounds and then do what? Put the negative. That's what I thought you were asking about, is the negative. But this one, the smallest is on the bottom, so I don't have to flip up the bounds and put the negative outside. So I'm ready to do the antiderivative. What's the antiderivative here? And because it's subtraction, I can split it up and I can just do them separately. So the antiderivative of x is 1/2 x squared. And the derivative of negative 10 minus 10x, this whole thing is being evaluated from negative 6 to negative, or from negative 4 to negative 6. So I do big minus little. Upper bound minus lower bound. Are you talking about here?
I was just like, why is there two? I think.
Sure. I could split this up by those properties of integrals and say this.
And that's why.
If I wanted to. You do the antiderivative of each one. Y'all asked? Yeah. Yes. Yes. Unless it says evaluate the antiderivative using areas. Yeah. That means let's look at it geometrically. If it says by areas, I'm using shapes, so I'm graphing. For example, if I had I'm sorry. I don't know. I pulled this one. Okay, 1/2 of 16 is 8 plus 40. 1/2 of 36 would be 18. 48 minus 78, negative 30. What y'all got? Uh-oh. I could have done something wrong. My math is right. 1/2 of 16 is 8.
Well, actually, I don't know what the 1/2 of 36 is.
18.
Okay, I did 16.
Okay.
It was close.
Use area to evaluate the integral. Mark that guy. Geometric. So what is it? What does that look like graphically?
That's why I don't know how to use it. I don't know how to do it.
When you're graphing, you just graph this and you find the area under. You can use your calculator, but you have to show your work in the setup and the. And remember though, your calculator, remember we talked about that second trace and we calculate the integrand and it shades it for you and it tells you what the answer is as you go? Okay, y equals and put this in there. Y equals and put this in there. Tell me what it is. It's a semicircle, right? It's half of a circle. What's the radius on your semicircle? 2. Because it's the radius, that means everywhere I go is 2. It's going to be the worst semicircle ever. All right, there's my semicircle. And it's asking for the area between -2 and 2. So I'm looking for all of this. So if I was asked to do this using area, and I need to show all my work, which you'll have to do, right? You can use your calculator to check, but you got to show all your work. So what I want to do here is find half the area of a circle. Well, how do you find area of a circle? Pi r squared. So half of a circle would be, so my area here of my, I guess I'll put semicircle, 1/2 pi r squared. Well, what's your radius? 2. So 1/2 pi times 2 squared, 2 pi. So this equals 2 pi. That's it. You sure? Area. Y'all are going to love trap rule when we get there. Yes. 1/2 height times base 1 plus base 2. What y'all ask me? Oh, calculator. Okay, while that's graphed on your calculator, go second trace. So I can't remember. I think it's number 9. 7. So lower bound first, and then upper bound. Well, pi's 3.14. So if you double that, right. So if you needed an exact answer, it's not giving you the exact, but it's a good check because 2 times pi, 2 times 3.14 is 6.28. So it's somewhere around there. Well, I say if I let you have a calculator and I say show all your work, setup and everything, then probably say, okay, here's a point. The check, right. But no, if you're in a multiple choice situation and they give you something like this, like if they give me this interval, I'm definitely using my calculator if it's a calculator problem. Just bound.
Oh no, I mean like before.
Oh wait, that's true actually. How did that?
The what? It's a circle. So the equation, this is a semicircle, so it's always going to be radius squared minus x squared for the semicircle. Because an equation of a circle is x squared plus y squared equals r squared if it's centered at 0. It's just it just doesn't take the negative of the radical. I can. Did you go -2 to 2 when you did it? If I hit 7 and then I do -2 and 2. You went 2 to 2, but that's one of the properties because if you don't change the bound, right? If it's the same number, it's just 0. It's just 0.
I forgot about is there any non-secular? I know that.
Before I get on to the quiz review, average value of a function, how do you find it?
Wait, what?
Average value of some function f of x on some interval. Yeah, 1/2 1/2 high times b1 plus b2. Got it? Average value of f of x on some interval from a to b is 1 over b minus a times the integral Yeah, I did. I do that a lot. I'm can be dyslexic sometimes.
What does that mean?
What does that mean? If I told you that f of x was if that's f of x, let's even I'll make it 1/3 x squared. And I said, what's the average value of f of x on, I don't know, from 1 to 3? One over 3 minus 1 times the integral from 1 to 3 of 1/3 x squared plus 5. Antiderivative and plug in. That's exactly right. So 2 plus 1 is 3. X cubed plus. So if I add 1 and then I take this number and I divide by it. So I had 1/3 and now I'm doing x cubed over 3, which would be x cubed over 9, which is 1/9.
What is the 1?
1 over b minus a. This is not when I evaluate an integral. This is when I'm asked to find average value of it. I don't know. I don't know what you could do. I don't know y'all gonna make me work it all out. It's okay. It's okay. It's always the upper bound minus the lower bound. Always subtract.
All right, now why is there a whole nother?
Whole nother what?
Oh. All right, that actually.
Average value. Evaluating the integral. You have to evaluate an integral to find average value, but it's just a little bit different. This one, you would start with just this, as opposed to starting with this. You use the evaluation of the integral to find average value.
Oh, no, I didn't.
One RAM real quick. Okay. I don't know. 27 divided by 9 would be 3. One night. Divided by 2. I got 58 over 9. I could be wrong. I did it really fast. All right, so this is 18. This is 5 point, oh, I didn't on the calculator. 5.1. So I got, this gave me 1/2 times 12.8888888 repeating. And when I divided by 2, I got 6.4 repeating, and then I just made it a fraction. Let's do a ram. Wait till we get the trap.
Unless you have a calculator.
Because what we're fixing to do is we're not going to use rectangles. We're going to use trapezoids for each thing instead of right. Trap rule. It's a more accurate. It's a more accurate. We'll get there whenever we get there. Thanks, Robert. Right.
Mac, that's what I was before.
I realized that once I started looking at it, I was like, I'm about to get
I'm going to Bush Pump Rock. Was it good?
No, I opened the door, but it wasn't locked.
You know,
what is it, a legendary? So they give us a free deal.
Oh, really?
Yeah.
Where is it? I'm gonna go there. Where is it?
It's on.
They have coffee.
I'm gonna make this one hard.
Just everything there was a.
It's like, it doesn't really look like a.
Okay, yeah, so your kids are going and now.
Everything there was. Like
All right. Here's what I want you to do. Two parts to actually three parts to this. First thing I want you to do is I want you to graph this and draw the rectangles in the area that you're finding. And let's do it. Let's say this is MRAM. We're gonna make it harder, and I'm gonna show you how to use your calculator.
They're not just medium.
Mid. Medium rare. How do you eat your steak?
There's some easy.
Definitely.
Wait, do you not just do?
I adjusted my window from 0 to 4 so I could see what was going on.
So we can't use the program you put on. Or
Huh? Well, not whenever it says do it by hand. All right, I want to make sure I get through this, so I want to get going. All right, so here's 1. 4 is way over here, and it says between 1 and 4. It goes up really high, yeah. Go from 1 to 100 on your Y and go by 10. And you'll see it. All right. So this is what happens whenever y'all ask me just to randomly think of something. But anyway, okay, so here's what I want to do. I want to find the area under here. So I'm looking for the area from here to here, right? But it says n equals 3. So that means I only want 3 rectangles, and the height of each rectangle has to happen in the middle of each. This is a lot. No, what?
What is this? What is
Okay. I'm good.
Why is the height?
Because it's MRAM. It's only for MRAM. If it was right RAM, then I would start at 2, 3, and 4, right. If it was left RAM, then I would do 1, 2, and 3 for the height. Okay, so it just depends on whether. Okay, so for this one, they're asking me MRAM. So I'm going to go midpoint between. Now, first of all, n equals 3. I should have said that. That tells me that my width of each rectangle, right, is the same each time. I'm going to do high minus low divided by the number of intervals I want. This happened to be an easy one because the width of each one is 1. This was easy to look at. The one you have will be easy to look at. All right. So I asked you not to calculate anything just yet, but simply to draw the picture with the rectangles in it. So from 1 to 2 is my first rectangle, but the height of it is going to happen exactly in the middle, which is going to be right here. So here's my triangle. I mean my rectangle. Golly, geez, Stella, you're rubbing off on me. And then halfway between 2 and 3. And then halfway between 3 and 4. Right now for what you know. Antiderivative is the exact one. That's what the one we would prefer to use. But yes. They will say, you talking about like which one's more accurate? Yes. And it will be based, you have to think about the concavity and the increasing or decreasing. Because this one's increasing and concave up, if you did a right ram, it would be an underestimate. If you did a left ram, it would be an overestimate. So midpoint ram would be your, it doesn't change concavity over the course of this interval.
But then they'll get
I haven't seen anything very confusing with that. It's been the ones I've seen have been very straightforward, and they have been in like a part B of an FRQ of explain why LRAM would not be a good fit for, well, that's because, or explain why LRAM is an under or overestimate of this, and you would have to talk about the concavity. So here, now that's all I asked you to do, right? Now evaluate MRAM. So you can use your calculator to kind of help you here, but if you have to show your work, here's how I'm going to let the calculator do work for me without actually letting the calculator do the whole problem. Exactly, exactly. This is already in your Y1, so go into your table, so hit second graph. This point is 1/2. I just need the Y value that accompanies it. Yeah, that's what I got. It's 1.5. Did you put 1.5 or 1/2 like I said?
Teacher part of the election. At this time, all ninth graders report to the auditorium at this time. Students should sit towards the front of the auditorium. All ninth graders. Thank you.
2.5, 11.75. Remember, this is the hardest part of it, right? And then 3.5 gives me a height of 24.25. You might have input something incorrectly. I bet maybe your 1/2 doesn't have parentheses around it. But remember, what you can do is you can put the width on the outside, since that's the same every time. It's 1, right? Because I'm essentially factoring the width out. And now I do height plus height plus height plus height plus height. So 3.25 plus 11.75 plus 24. That's your, yeah, that's your width. That's exactly right. And it's the same each time. Which you should get, again, go back and check, run that RAM program for this, and make sure you get the same thing. So come back out to your main screen, hit program. You should see RAM there, so hit enter. Then you should be prompted to give the number of intervals, and then your upper and lower, or lower and upper. I don't have it on this one, but enter. Yeah. All right, just quickly, and then I'm gonna let you get started. You will. We have literally done every problem on here with different numbers. Except for one thing real quick. What if, this is a very basic example for the sake of time. What if I asked you to find, let's see, 1, 2, 3 intervals left RAM from 1 to 4? That's exactly right. It's way easier with a table. All right, so if I do left RAM, and I'm doing this from 1 to 4, and my n is going to be 3. So I'm going of width of 1, right? So here's rectangle 1. I literally, every time I work these, I draw my rectangles on here. It helps me see it. So now if I want the left endpoint, remember I do the width. The width is constant. Again, this is an easy one. Check your width and make sure that it's, but the width is constant. If I'm going left RAM, then I'm going to do the left end of this one, and the left end of this one. I shouldn't have more than 3 numbers to add in there because I only have 3 rectangles, right? As opposed to right RAM, which would be, I wouldn't use the left endpoint, I'd start here with 8. That's my timer to say it's time to take quiz. Right. And if, well, in the middle, you couldn't do a midpoint on this unless I only asked you to do like 2 sub-intervals or something, and then you went and you found halfway in between and you used like, it's not good to use them. You don't want to average your y's together. Average your x's together to get the exact y, but you don't want to.